All right, before we move forward with rigging, we're going to have to explore a concept called constraints. So let's come up here to a new scene. Make sure you save if you haven't yet. I've already saved one, so I'll refresh my save there. But we're going to look at a particular kind of constraint called a parent constraint. Now, let me set up some objects here so we can have some context. We'll go ahead and do a sphere, and we'll go ahead and do a cube. We've looked at parenting, and that's where if we want to use hierarchies, we can use them to make one object control another. So for example, let's say we wanted to make this cube controlled by the sphere. I could select the cube first, shift select the sphere, press P to parent, and that's going to parent them together. So now the sphere is going to move the cube. But what's unique about a hierarchy relationship is that the cube can still move independently. So it can move over here, and you can see the sphere can continue to control it. So if we want something to be able to move independently while simultaneously moving with something, a hierarchy is going to do the trick. A constraint's a little bit different because it removes the independence. So let's go ahead and just Shift P to unparent these, and I'll zero them out real quick. So that way that's back at the center. We can zero out this one's rotations. We can find constraints by switching over to our rigging menu set. So you'll see up at the top here, I've already done so. I've switched to rigging. And we can go to a section here called constraints. Inside of the constraint menu, you'll see that there are several constraints you can pick from: parent, point, orient, scale, aim, and pull vector. We're going to take a look at several constraints in this course, but the main constraint that we use is called a parent constraint. This is where things get a little bit confusing because when we're creating hierarchies, we're doing a parent-child relationship, but that's a bit different than we're doing a constraint, and we also have parent constraints. So what's the deal with a parent constraint? Well, the term parent is to refer to that parent-child relationship a hierarchy has, but pairing that with the concept of a constraint. So when you think of something that's constrained or has a constraint on it, you might think it doesn't have the ability to move, right? So if someone was constraining you, that would mean that you're probably not able to go anywhere. That is the idea with these, is it gives you the parent-child relationship, but the independence is lost. So how does this work? It works in opposition. When we do hierarchy-based parenting, it's child parent P, but when you do constraints, what it is controller, controllee, and then you press parent. So if I wanted the cube to be controlled by the sphere, what I would do is I would select the sphere first, I would select the cube second, and then I would come up here and I would utilize the parent constraint to constrain those together. So let's take a look at how that works. I'm going to select the cube second, so sphere first, shift select the cube, constraint, and click parent. Now, when I do this, you're going to see a couple things happen. If we take a look at the cube, you're going to notice that the cube has its channel box turned blue. And in addition to that, in the hierarchy underneath it, it has a constraint. When you see blue in the channel box, that's going to indicate some sort of constraint. And more importantly, what it means is we can't keyframe this without it breaking something. So there are conflicting arguments inside of Maya, meaning that if you tell it to do one thing and do another, they counter each other out. Constraints are going to be one of those things. So if you were to try and keyframe this, you're going to get a problem. But if we take a look at the sphere, we can see we can move the sphere now, and we can move the cube. Something unique, though, is if we try and move the cube, you see it will move, right? So we could put it over here, we could rotate it, whatever we want to do. But the moment we move this sphere, it snaps right back into place. So these movements are just artificial, meaning that they mean nothing to Maya. We can do them, but as soon as it goes to evaluate the movement, it's going to be back on its pathway. So that's one of the big differences between constraints and hierarchies, is that when you do a constraint, that freedom of the child to move independently is lost. Another unique aspect, though, is that they work independent of hierarchies. So notice that these are not in a hierarchical relationship together. The cube is not underneath the sphere. The cube is its own independent object. This is very useful when we want to make one thing separate from another. So for example, when we're building out a character's rig, we don't necessarily want the rig to be tied into the character. because we might need to do other things to that character. Or, for example, when it comes to games, we'll need to export that character, and we don't really want the rig going with it when we take it into something like a game engine. So it's important that we keep our rig separate from our character as much as possible, and constraints are going to allow us to do this. All right. Now, there's a lot more to constraints to be aware of, and we'll explore those as we go. But at a base level, this is going to be what we're going to need to know for this next section. There is one more thing I want to show you with constraints, which is the ability to jump to a location. So let me pick something here that we can see clearly through our sphere. I'll just pick a tube or something like this and scale it a bit. That way it goes around our sphere. We'll go ahead and make Saturn here. So another really useful aspect of constraints is not just the ability to make them move with an object, but to make them jump to another object's pivot. So you'll see that the pivot point of this sphere is its center, and the pivot point of this object is its center. We could try and eyeball these to make them perfectly in place, or we could just use the options in the constraint to accomplish this. I can select my sphere first to be who's in control. I can shift select my pipe here to be what is controlled. And up here in the constraint menu, rather than just pressing parent, I can go into its options, and I can uncheck this section here called maintain offset. What maintain offset does is it keeps the distance between the two objects permanent in the constraint, meaning that it will always maintain that set distance. But if you uncheck maintain offset, what it does is it jumps to the location of whoever's in charge, to their pivot. So I can uncheck that and hit apply, and now you'll see that I have this perfectly around the center there. And as I move, you'll see that this will be perfectly in the center all the time. And once again, notice it's not in a hierarchical relationship, it is separate, which is really cool. This can be used for both rigging and modeling. The trick to using it in modeling is once you've placed it, you can come into the pipe, you can expand out its hierarchy here, and you can select the constraint to delete it. So we can select that constraint, hit delete, and it will get rid of that. And now you'll see that this object can move freely with this object being placed there. We could even go a step further and we could use a hierarchy here. So rather than making this work with a constraint, I could select this as the child, select that as the parent, and press P, and you'll now see I placed it with a constraint, but instead we're using a hierarchy-based relationship. So we've undone the constraint just so we could have the placement. Okay, so that is one of the other aspects of constraints that's very useful, is the ability to move those to location. Going back into the option box, I do want to cover a couple more things because they're important just in the off chance that they happen to you. So let's go ahead and create 2 cubes here for our demonstration. We'll keep the sphere as our master here. We're going to shift select the cube here to be controlled. We'll come to our constraint parent, go into the options here. I'm going to turn back on maintain offset. And what I want to talk about next is the constraint axes here. You'll see that it currently has translate and rotate, and then it has separate channels in between. You can specify which one of these is going to be the active channel being controlled. You can even do just specific axes, and this gives you a lot of freedom if you want to create some pretty crazy effects. So for example, let's say we only wanted this to rotate with this. We didn't want it to translate. I could uncheck translate and hit apply. And now when this object translates, you'll see that cube does not move. But when this object rotates, that cube does. So there's a lot of interesting things you can do with this, with having them broken. Most of the time they work in tandem, and we'll take a look at that when we get into more advanced rigging techniques later on. But you can separate those out, and you can even make it so only individual channels operate when one operates over the other. And that can be useful when you're creating various things like mechanical rigs, or perhaps reactive animations. Doing it in the translation setup here, if I were to select this and shift select this and do translate, we could hit apply. And now you'll see that will translate with it, but it won't rotate with it. As a matter of fact, notice what the rotation does here is it stays level, which looks kind of neat. So as this translates, that cube stays facing in the forward direction. Something else to be aware of is you'll notice that the channels do not gain a constraint, meaning that if you wanted to, you could still animate these, or you could make something else control the channel of that asset. So for example, this one has no translates, which is this one here. This one has no rotates. We could make these interact with each other. So for example, if I wanted this one's translates to control this, I could select this as the master, select that as the driven, and hit apply. And now that one's translates are going to control that object, but the rotates of the sphere are going to control that object's rotates. So you can start to get to some pretty wacky things here. So just got to keep that in mind. There are a lot more things to know about constraints, but I want to keep it at the bare basics that we need to know for now, not to overload your brain, but just to stay on track with what we need to know for the task we're trying to accomplish. You can always read up on constraints in the Maya documentation if you want to get to know more about them, and you can experiment with the other constraints here as you see fit. Okay, so that's going to be one of the first things we need to talk about is those constraints. Next, we're going to utilize those to set up our control rig. So let's go ahead and give that a shot. Before we do though, as a mini challenge, what I would like you to do is open up a fresh document and using some geometric primitives, just go ahead and play around with the parent constraints to get to know how they work. When you're done, make sure you come back in here and you reset these. So make sure that maintain offset is checked, make sure translate and rotates are both checked and hit apply. And then you're ready to move forward. Okay, so just make sure you reset that when you're done, and we'll go ahead and start building out our rig now that we have the tools we need.